All right. Good afternoon, everyone. We're going to take a look at the January 2015 written response. You did the multiple choice. We didn't go over the answers, but I did post a video of me explaining it last week. So we'll go over that, or you can go over that on your own time. I did mess up. I meant to, with the Google Forms, to have usually I have that app that sends you an automated email like, oh, you got these ones right, this one wrong. But I forgot to put an email question, so that won't happen again. So let's start with the first written. If you came a little late, I was explaining to everyone probably in 45 minutes. I mean, if we were working kind of quick and briefly explaining, we could probably get through the written, but obviously explaining and taking time and things like that, questions. So we're going to skip around here or there, but we'll start with this one. I'll give you guys a chance to read it. Some of you guys also have said hey, I kind of looked at these after I did the multiple choice. That's fine, but still, it's not like you have to leave. You might have got stuff wrong. You could say just to kind of listen to the explanations as well. So this one, we're dealing with a rational, irrational case. Again, I'll give you a minute to get started here. Settle in. We'll do some together. Won't give you time for all of them. What's up? Thank you. Can I help you? You're just awkwardly staring at us. Okay. So what do we think about this? Is Patrick correct or incorrect? What would we say here? So Patrick said it's irrational. Patrick answered that the sum would be irrational. He's correct. Now, so this is a 2-point question. Let's break down some point stuff here. He is correct, and that is the correct answer. If we just write he's correct, but we're not sure of the explanation, we just put that. How many are we getting out of 2 so far? 0. 0. We're not awarded any points for a 50-50 guess. You could flip a coin on this, and so the 2 points lie in the justified. Now, you can get a 1 out of 2 if some of your reasoning is slightly off, but if you just guess, if you just put Patrick is correct, period, they're not going to give you any points for that. Did you really doing it? You could have just guessed on a 50-50. Okay. So he is correct, but more importantly here is the explanation. Patrick is correct. Now, why? Does anyone want to tell us, type out? Sarah said rad 2 is irrational, which means it goes on forever. So even if you add 4.2, it will be irrational. Okay. The sum is a decimal that's not repeating. That's a good explanation. You can also use, I'm going to kind of write informally here, but rational plus irrational is always going to be irrational. There's no special case or anything and Sarah was kind of getting to it. If something goes on forever without a pattern and you add something to it, it's not magically going to stop. Now you can give other things. You can say the sum is a non-repeating, non-terminating decimal. You can say, in my opinion, the easiest thing for questions with rational, irrational stuff is one of 2 things. It's this doesn't have to do a perfect square, Zebra. I think that's what you meant to say. It can or can't be written as a fraction. That's, in my opinion, the easiest thing to remember. So yes, it's irrational because it can't be written as a fraction. Yes, it's rational because it can be written as a fraction. In my opinion, that's the easiest explanation, but there's a bunch of things you can do here. The sum can't be written as a fraction a over b, where a and b are integers. What else do we say? Non-terminating, doesn't stop. Non-terminating, also non-repeating you have to add if you're going that route, because 0.3333 doesn't stop, but there's a pattern. So it's a non-terminating, non-repeating decimal. A few things. Okay. So 2 out of 2. All right, this one I'm going to skip. This one I'm talking about. I'm skipping it. You were oh, we did this question last week, or a week and a half ago. You saw a question like this. It's just reading a 2-way table. All right, this is the next one we'll settle in with. I'll give you a chance to read it. Another 50-50. So go with the logic I just said. You guessing doesn't get any points. So once again, we want to pay close attention to how we explain it. So 50-50, -4, 1 or 1, -4. Which one would result in a relation that's no longer a function? So which point would not give us a function? Yeah. So it's going to be -4, 1. Let's say again, I just put this on my page. I'm like, I don't really know. I'll just put that. I'll get half credit. 0 right now, right? 0 right now. So yeah, it depends, Yusuf. But like, if there's a 50-50 or like a yes or no, correct, incorrect, they're not going to award you for that. Like, if we pull this out of nowhere, then that's a different problem. But anyway, why is this no longer a function? So functions with this deal with the idea of like x repeating or not. So this would cause the case of the input of x having two different outputs. So one x value would belong to two different outputs. Excuse me, no longer a function. Because the whole idea with this was like, again, I'll kind of write informally, like x can't repeat. Right? Remember that? You wouldn't want to write that as your explanation, but like -4, 1 and -4, 2. You have x repeating. It goes to two different y values as well. 1, -4 would be perfectly okay. Now you might be saying, wait, doesn't that repeat too? It doesn't matter if the y repeats. It's with functions, it's all in regards to x. Yeah, x repeats. I would probably, I know I'm writing it informally, Abram, but I would probably more so say something along the lines of like, this would create one x value with two different y values, something like that. Yeah. Okay. Another one, not so bad. All right, let's set this one up together. We got some polynomial stuff. This is, in the grand scheme of things, also not, earlier in the year we did this, pretty basic. We're going to subtract 5x squared plus 2x minus 11 from 3x squared plus 8x minus 7 and express as a trinomial. I don't know what, they could just say put in standard form. Saying trinomial doesn't really do anything for us there, but all right. Now, there's a slight trick with this. What's the slight trick? We've seen this, so it's not really a trick anymore. Maybe not. What's the trick? Change the order. Subtract from. Good. Subtract from does what? Switches. So I'm going to put this first, and 5x squared comes second. Now, I'm going to get this wrong if I leave it like that. I'm going to get this wrong if I leave it like this. So what else should I do? Parentheses. Yeah, I want to subtract this whole thing. Oops, I also forgot the squared. Okay, so distribute the negative. Right, this way I'm really subtracting everything in that second trinomial. Okay, and now combine your like terms. So my like terms are 3 minus 5 is -2x squared, 8 and minus 2x. Remember, include the sign when you're doing this. And then -7 and positive 11 is +4. And I get a trinomial. That's your answer. Okay. Questions with that one? Does it matter the order you write your answer? Because they didn't put standard form, I guess you could get away with it, but just to be safe, always put it in standard form anyway. They technically just said write a trinomial, but always go from highest exponent down. Yep, this is 2 points. The lowest a written could be is 2 points. And there's 8 2-pointers. So there's a bunch of these easy quick hitters to start. Then there's 4 4-pointers, and then 1 6-pointer. Yeah, the 2-pointers are pretty simple. Every so often they put a 2-pointer where you're like, whoa, that could be a 4-pointer. This might be like a good example. Like this is something like, oh, this is kind of annoying. Okay. So this should come up. We shouldn't be so rusty with this. We haven't reviewed it yet, but also something we did not so long ago. What are some takeaways you have with the question before we even talk about how to solve it? Huh? So I see the word algebraically, which tells me what? Show your work, right? I can't really use like stuff on the calculator, like the root feature or something like that on my calculator, right? I can't magically look at my friends next to me. So we have to show some process. We either have factoring, we could do CTS. Just looking at this one, probably not CTS. So what else can we do? If it's not factorable, we're not going to want to do CTS. What could we do here? Could do quad. Quad's always in our back pocket, and that's given to you on a reference sheet, so you don't need to memorize that. But our best step is to see if it's factorable. Like, give it that little effort here. You can kind of already see like the motion of, hey, this might work. If I'm gonna factor it, or even if I am gonna do quad, what do we have to do first? Move the 7. Okay. Now, if we are gonna factor it, we want to look for a GCF. I don't see any GCF. I'm gonna do my eyeglass game. AC. And again, I might be doing this all right now, and then I find out it's not factorable. It's annoying, but still probably going to be faster than doing quad. And all of a sudden, all right, I see this is going to work. I know it's a positive and a negative, and this does work. Negative 14 and positive 2. Now let's do our trash. Whatever this number started with is going to start our 2 bubbles for a moment, temporarily using it. Put the 2 numbers we just found. And now we're going to throw away a GCF of 2, and we're going to throw away a GCF of 2. Now we're not done yet. We factored it, but this question was asking us to solve it. What do I do to solve it now? T-chart. Good, Sarah. We set each bubble equal to 0. You don't want to mess up at the finish line here, so take your time solving the 2-step equations. Move the 7 over, move the 1 over, and we get x equals 7/2 and x equals -1/2. So 2 answers of 7/2 and -1/2. Now, very quickly, what if you did do quad? Let's see. Trying to do it in my head, sorry. 12 plus or minus 256 all over 8. 256 is 16. Now you could do the math here. 12 plus 16, 12 minus 16. And these fractions are going to work out the same. 7/2 and -1/2. So quad formula is just going to work out. The radical just goes away because 256 was perfect. Okay, I would personally recommend factoring whenever possible. Give it that extra effort of like, let me check if it factors. If not, I could always resort back to quad formula. Questions with this one? Take a little pause. The formula is on the test. Yep, it comes on the, I'll show you, Lucas, because this packet includes like what you get. So you get this little sheet. A lot of stuff is like irrelevant because they just make the same sheet for all 3 Regents classes. Like, don't get scared that you don't recognize a lot of these, but it's right here. Ta-da! Okay. All right. How are we doing so far? Oh, baby. All right, what do we got for question 30? What do we call this guy? What do we call this guy? Piecewise. Piece. I before E, Grace. I before E. Okay. A nightmare. Okay. So let's make our 2 mini tables. I am eating. I'm eating. This lesson is brought to you by it's like a peanut butter stick, and then you dip it in like jelly. It's good. Okay. So we're gonna make our mini tables. Luckily, these are pretty easy functions. Sometimes with piecewise, you're given like a crazy function, but these are pretty basic. That's the parent absolute value function, so we can almost like do that in our head. And that's also f of x equals 4. What is that gonna look like? Yeah, well, every line is straight, Abram. Horizontal. Yeah. Okay. So if you want to, like I said, you could probably do this without showing a table. Oops. You could do this without showing a table, and you don't need to, but it's always good to have it just in case. You don't lose points if you don't show this or something. At -3, you're going to have a closed circle. At +1, an open. I can't, if you're like, wait, didn't you tell us you could just use the beginning and the end? That's only with lines. If it's any other type of nonlinear function, we have to do everything in between. Now we could just take the absolute value of each number. This is pretty easy. All right, and 4 is also going to be easy because every output is 4. And on this one, I can use the trick. I'm going to use the beginning and the end because it is a line. And this is both closed and closed. Now, how am I getting the open and closed? Can anyone tell me how I'm determining whether it's open or closed?
Like with the less than equal sign, it has a line under it.
Good. So if it has an equal to, we're going to use a closed circle. If it's just like less than 1, we have an open circle. All right, now I'm going to go ahead and plot this. No arrow on the left side. This is one of those things you might be used to graphing it. How come I'm not putting an arrow? This graph specifically tells me to stop at -3. Doesn't go on forever. Okay, and now I pick up at 1, 4. And I go all the way to 8, 4. Once again, no arrow there. Rachel, what's up? There's no follow-up. So this is kind of a piecewise as a 2-pointer is kind of annoying, but there's no follow-up. Technically didn't have to show a table. They kind of put easy functions in it. So it's annoying to have a piecewise as a 2-pointer, but they did kind of make it simple. What's the link for the graph thingies? I'm not sure what you mean. You could just print this paper if you want. Oh, the graph paper? You might have to dig a little bit on Classroom. Yeah, find a template somewhere. I don't have one reposted yet. Or yeah, Anne has a good idea. Just search for graph. I'll repost it. Okay. Cool with this one? All right, cool. All right, so this one's actually a system. So this corresponds, and we have 2 more part 2s. This is a system, and it also has a little bit of a trick in there. It says type A is 3 feet tall. It grows 15 inches per year. Type B is 4 feet tall, and it grows 10 inches per year. Algebraically, once again, what am I thinking? Like, hey, I have to show a process to this. I can't just put, 5 years. I got to show some equation, some work. How many years will it take for them to be the same height? So what's our strategy here? I'm going to create an equation for type A, create an equation for type B, tree A, tree B, whatever. And then I'm going to set them equal to each other because this will tell me when they'll be the same height. So let's start with tree A. It says it's 3 feet tall and it grows 15 inches per year. Now your first instinct is to do this, right? An expression like this. Anyone tell me what's wrong with that? Yeah, there's this feet and inches thing. So I can't use different units and have the numbers mean the same thing. It's easier to make the feet into inches. Because that just involves me multiplying by 12. To make the inches into feet is going to involve fractions because I'm going to have to divide them by 12. So I'd much rather instead say, hey, 3 feet is really 36 inches, right? And this is all coming from the idea that 1 foot is 12 inches. So that's where that comes from, right? I multiplied the 3 by 12. And same thing with tree B. So instead of 4, I'm going to say 48 plus 10x, 10 per year, where x is the number of years in this case. Okay? 10 and 15 are kind of like the slopes of the problem. So now, if I want to know when they're going to equal the same height, I don't want to just play the guessing game. I could algebraically set them equal to each other. Excuse me, set them equal to each other. Okay, I'm going to move the 10x to the left. I'm going to subtract 36 from both sides. I get 5x equals 12, or x equals 12 fifths. Doesn't say anything with the rounding, so I'm just going to say 2.4 years. Does say exactly, so just leave it like that. Don't be like, oh, should I round 10 years into? It says exactly, just say 2.4 years. That's fine. Don't panic because it didn't work out. That's the answer. Okay, so we wrote an expression. We had to convert feet to inches to make sure the units are consistent. You could technically set the inches to feet. That's just going to be more annoying because you'd have 3 plus 15 over 12 and then 4 plus 10 over 12x. This one, at least, you get more whole numbers. You could check by plugging in, Ethan. I wouldn't recommend solving it by plugging in because look at our answer. Like if you're like, oh, I'm just going to guess 1 year, 2 year, 3 year, you would have never got it because it ended up being a decimal. You could check by plugging in. Don't solve it by like guessing. That's probably why they did that as well, because they figured people just guess like easy common numbers. All right, last part 2. Ooh, this one I liked. This is another part 2. It's like kind of annoying. So we have to come up with the equation of this and then explain how we got it. There's a few ways we can come up with the equation of it. All right. So the first thing is, if we're going to create an equation, we got to know, hey, is this a line? Is it a quadratic? Is it absolute value? Is it whatever? So what type of function do we have in front of us? What type of function do we have? Good, Kira. This is exponential. Does anyone know the model for an exponential function? Like mx plus b for a line? What's like the generic form of exponential? What's the generic exponential equation? It's not y equals mx plus b. What's the generic exponential equation? We don't know this? Good. Yeah, a times b to the x power. This was like, you know, your 101, the first day we did exponential functions. I said this is the generic form of that. X squared, Grace and Evelyn, would be a quadratic, right? Quadratic. A times b to the x is the generic exponential, where a is the y-intercept, and b is like, hey, what are you multiplying by? Common multiply. What? The common multiplier. Like, so if there's a pattern of times 2 or something, b would be 2. Lucas said, we learned that? Yeah. Yep. Okay. So what's kind of annoying is you might be like, okay, I'm just going to look for the y-intercept. Does anyone see a problem if we just went to look for the y-intercept? I can't really tell what it is, and I don't want to guess. I know it's between 0 and 1, but I don't want to just eyeball it. So what we're going to do instead is find nice points, things we can at least pick out. So this is a nice point. Does anyone see another nice coordinate we could actually put a dot on and know exactly what it is? 3, 2 is another nice one. Good. Now let's write these down. So we have 2, 1, and we have 3, 2. Okay. You could also pull out another one if you really want to. There's a few here. So this is good because we could at least find the common multiplier. Like what's happening between consecutive outputs? What's the pattern here in multiplication? Yeah, there's a pattern of multiplying by 2. So that gives me the b value. That's the base. And I'm going to explain after. You could also use your calculator for a question like this. But it's not bad by hand. All right. Now, we knew that we don't know what the y-intercept is, right? And if we're going to write this by hand, we eventually need to know it. But we could use that pattern to help us work backwards, kind of like what we did with sequences. If I know it's multiplying by 2, I could work backwards by dividing by 2. So what is the coordinate, the y-coordinate at 1? Using that logic, working backwards and dividing by 2. What should the y-coordinate of 1 be? 0.5. Good, Grace. And now let's do it one more time. What should the y-intercept be? Working backwards one more time. 0.25 or 1/4. Excellent. And now let's put it together. We know the y-intercept. We know the common multiplier. The equation here, did they give me a name? Nope. Let's call it f of x is going to be 1/4, parentheses 2 to the x power. Okay? And the good thing is, if you were doing it this way, like kind of showing your work, your explanation is going to be very easy because you could just be like, I did my work over there. I used this model. Like, you don't have much to explain. Now, it doesn't say anything about doing this algebraically, so you could use your calculator. Now, how would you use your calculator? You would still need to find at least 2 nice points. So let's just say 2, 1, and 3, 2. You would type this into your list, and then instead of doing a linear regression, you can probably see where I'm going now. Once you type them in, there's another option called, not very common, and it's kind of hidden. It's called xbreg at the bottom. So it will create an exponential function that goes through those 2 points. If you just choose linreg, it's going to create a line that goes through the 2 points. So if you use xbreg, that's fine. Now your explanation, if you did use exponential, would be just kind of detailing what your steps were on the calculator. Not like, I moved my fingers 2 inches to the left. No, you could just say like, I used the stat xbreg feature on my calculator. That would be perfect. Okay? This was a kind of a non-traditional question, like not a common one, but this is something that we did. We definitely learned exponential functions. Are you being serious? Okay, yeah. I can't tell if you're being serious or not, Lucas, but yes. Okay. For 33, Jacob and Zachary go to the movie theater, blah, blah, blah. This question is almost like an exact replica of what we saw today with the pizza and soda. So we're going to write a system. We're now entering the 4-point territory. We'll also tell you, right? Each correct answer will receive 4 credits. Blah, blah, blah. Show your steps. They're just reminding you, like, don't make this mistake. Let's set this up. So they didn't tell us any variables. So just to be safe, technically they don't take off for this type of stuff, but it's a good idea to use let statements. So what are our variables here? Popcorn and drink. So I like to keep it very literal so I don't mess it up myself. If I use X and Y, I might make a mistake. If I use like the first letter, it's going to be less likely. So let's use P and D here, popcorn and drink. Okay, can anyone tell me one of the equations we can write here? Read carefully. We saw today, like they had that trick. It said like 5 friends and each of them gets 1 drink. So some people made a mistake that year on just putting 1 drink. Jacob spends $18.25, 2 bags of popcorn and 3 drinks. Good. So 2P plus 3D should be $18.25. And then 4 popcorns and 2 drinks is $27.50. Okay, so that's our system. Right now, we have a 2 out of 4. Okay, we have a 2 out of 4 just by creating it. And then it says, using these equations, determine the price of each one to the nearest cent. Oh, I forgot why they did that. Does this one not? This one might work out kind of weird. Let's see. So how should we solve this? We talked about systems in our review today. We have sub or elimination. What do we want to do? Sub or elimination? I would probably say elimination. Yeah, Mark. I would do -2 up top. We could do a single elimination by doing -2 up top. If you wanted to eliminate D, you'd have to do a double elimination and say like times 2 and times -3 maybe. So multiplying by -2, I'm going to rewrite the bottom one up top now and do times -2 carefully. Write that underneath, stacking it. We get -3650. Okay, we get -4D equals 2750 minus 3650 is -9. And we're going to end up getting $2.25 per drink. Pause there for a moment. So we multiplied by -2 to create the -4. I kind of switched their order up, right? I added them together. That tells me the price of a drink. You wouldn't want to do sub here because nothing was close to being solved for. For substitution, you have to get a variable by itself. Like if you were able to get P by itself, and then you'd plug into the other one. Now, we're going to substitute D into the either equation. Let's use the bottom one. Slightly smaller number, I guess. We get 4p equals 23. Now 23 divided by 4, we're going to get 575 for the popcorn. Your work might be a little messy, so it's a good idea to kind of just state your answer more formally. This way the person grading it can just kind of clearly see. It's even write it in words now. So a popcorn is 575, and a drink is 225. It's a good idea to have kind of that concluding line. This way someone doesn't have to dig through your work or like try to find it or they're not sure where it is. Okay, questions with that? Yeah, you wouldn't want to do sub here. Sub works best when one variable is either already solved for or very close to being solved for. Okay. Questions? All right. We getting there? We getting there? Ooh, I like this one. Hold on. Let me just look to the rest. All right, this one we'll skip. We kind of did this one. This is just regression. If, like I said during the stat test, if you see this as a part 3, this should be a layup. As we learned, this is just typing it in, writing down the R value, and saying if it's strong or weak. I mean, come on. We'll do that one. Okay. Ooh. Yeah. And we might have to skip 37. Okay. So we have a few more at least. We have like 9 minutes. We could do it. So write the inequality represented by the graph. So we're going to start by doing, we have to worry about the symbol. We'll leave that blank for now, but let's focus on M and B. We know it's a line, so it's going to follow that form. It's not going to be equals to, right? It's an inequality. So we have 4 choices for the symbol, but we'll worry about that last. Can anyone tell me the slope of the line they see in front of them? We're going to assume, if nothing, it's 1 by 1. The slope is 2. We go up 2 over 1, right? So that's going to be our slope. And again, that comes from, choose like a nice point. You can see that you're going up 2 over 1, up 2 over 1. Slope is rise over run. So that's going to give us the 2x. Now the y-intercept is going to be where it hits the y-axis. So in this case, we could also clearly see that, not like the exponential one earlier, happens at -3. So now for the symbol, we have 4 choices. We have greater than or equal to, less than, or less than or equal to. So what sign should we have here? Yeah, greater than or equal to. It's a solid line, so it should be or equal to. If we had a dashed line, we'd be looking for greater than or less than. So why is it greater than or equal to and not less than or equal to? It has to do with the shading. This is shaded above the line, above the line. Remember, it's kind of like word association. Above goes with greater than or equal to 2x minus 3. Okay. On the same set of axes, we're going to graph the inequality. So before we graph it, anytime we're graphing a line, we should get y by itself. So I'm going to subtract x from both sides. And now I'm going to divide by 2. Just be careful with inequalities. Always be thinking about flipping and stuff. In this case, I don't have to flip. X divided by 2, I'm just going to make that into a 1/2. 4 divided by 2, I'm going to make it into a 2. And again, I don't have to flip here because I didn't divide by a negative. Now, there's 4 pieces of information we need to graph it. We need to know M and B. We need to know what type of line, and we need to know where to shade. And if you remember, when we graph it, I like to write these down. This way, when you go over to your graph, it's a very easy transition. M and B is easy. M is going to be -1/2. B is going to be 2. What type of line would this be? Is this going to be a dashed line or a solid line? Good, dash, dotted, whatever we called it. I always mess it up. Dash, dotted, same thing. And shading, should we shade above or below? Below. Say the symbol out loud for that. Less than, below is the association, right? So graph your line first. Begin at 2. We're going to go down 1 over 2, down 1 over 2. Since it's dashed, don't make a solid line and try to erase it. Doesn't ever work out. So what you would do is you lay your ruler down on top of your points and just kind of pick it up every so often. Or if you're really cool, you could do this. Okay, dash line and shaded below. With shadings, kind of like how they have it, just put lines underneath it. Sometimes the computer on it, like the questions will have literally like a fully shaded. We don't do that when we're doing it by hand. Get rid of this guy from earlier. Just have lines jutting out, touching the line that you graphed. That's it. You don't need to label here because it wasn't really a system, but you can just to be safe. All right, and there's another follow-up. This is a lot of work. The two inequalities form a system. Oscar thinks that the point 2, 1 is in the solution set. Is he correct? So let's find out where 2, 1 is. We'll kind of highlight that. 2, 1 is right here. Put a nice red dot. So is he correct? Oscar says that's a solution to this system. Anytime we have a yes or no, we don't want to just say yes or no and then stop. Is Oscar right or wrong? Oscar's wrong. Remember the definition for a solution, whether it's a system of inequalities or a system of equations, the definition of a solution is it satisfies everybody, satisfies all the parts. Does that red point satisfy both inequalities? No. Satisfies the black one that was printed, but doesn't satisfy the purple one that we just did because it's a dotted line. So you can keep it very simple. You could just say it doesn't satisfy both inequalities. Keep it simple. You could even add like dotted line or something. You don't need to show it algebraically and go that crazy, but that's perfect explanation. You don't need to add exclamation marks either. Okay. We'll probably get one more done. I wasn't crazy about 37, so I don't mind that we're skipping that one. This was kind of a weird one. All right. So for 36, and I will post the answer key for all of this, the recording as well of this lesson, but the January 2015 answer key that I have, I'll post. So given the function f of x equals -x squared, state whether the vertex, which we don't even know where it is, state whether it represents a maximum or a minimum point and explain. So we can answer this right away, believe it or not. Is the vertex, which we don't even know where it is it a maximum or a minimum? It's a maximum. How do we know that in 2 seconds? Yeah. Because of that negative sign, this quadratic looks like this, which means wherever the vertex is, it is going to be a maximum. And we want to explain. So the vertex is a maximum because A is negative. The vertex represents the largest output or something like that. I don't know. You even have like a little picture like that. Okay, so that was pretty easy so far. Minimum would be like the smiley face. In that case, the vertex is the lowest point, right? The smallest value. All right, now it says rewrite f of x in vertex form. We can't even cheat. It says by completing the squared, which means if they name a process, they want to see it taking place, right? They want to see us completing the square. All right. Now this one, you might have to have a good memory. We did do a lesson on this. It's called vertex form. We talked about like converting between forms, right? Like how to take it from vertex to standard is pretty easy. It's just box method. Now how to go from this to vertex was a little bit more complicated because you have to use CTS. Does anyone, and we can't even cheat and be like, oh, let's just find the vertex and plug in the numbers. No, because they said completing the square, we can't use that hack. Does anyone know what the first move is here? The first move is the most important. Divide by -1. Very good. How come we have to do that? Why are we doing that step? Seems kind of pointless. CTS only works when a is equal to 1. A did not equal 1 when we started this. It was -1. Now, the other thing is, this is not equal to 0. So it's not like we divide by -1 and it like goes away. Notice how the negative sign is still there. That's going to come into play at the very end when we have to kind of put everything back. Okay? Now, what I like to do is move the 9 out of the way. So I'm going to do that by adding 9. And now comes the stage where I'm going to add some number to both sides. I didn't give myself space for it on this side, so I'll just put it like this. What is that number that I'm going to add to both sides? 16, Abram says. And he's right. The number that you're going to add to both sides, the little formula is b, which in this case is -8, over 2 squared. B over 2 squared. So you don't even have to worry about the sign because you're squaring it. 8 over 2 is 4, squared is 16. So do your math on both sides. I'm adding it to both sides because that balances out the equation. And now that should be a perfect trinomial, which means it's going to be the same bubble twice. Now you could also hack this. If you remember, what should your binomial be? What should your bubble be? You don't need to sit and do some product. I showed you guys a little shortcut. It's going to be half of b. Yeah, it's just going to be x minus 4. This number will always be half of this. You could sit and do some product if you want, but that's always going to be true. All right, now we have to we got the square we were looking for. That's what vertex form has, right? Now we have to put everything back so it's a normal looking equation. This isn't very normal looking right now. So first thing, I'm going to move the 25 over. Minus 25. Not done yet. Now remember our very first move, how we divided by -1? Now we're going to divide back by -1. So everybody gets divided, the bubble and the 25. So my final answer is going to be f of x equals. Now the negative sign can't go into the bubble there. The negative sign can't go into the bubble there. It's going to go out front. PEMDAS rules and all, right? We can't divide by something that's being raised to an exponent. The 25 can. So the 25 is going to become plus. And that is our answer. Okay, I'll zoom out. We're not going to do question 37. We'll stop after this, but any questions with that? Kyle, I only said it during class, dude. It goes like this. Numbers 24 through 32. So that's 8 questions, or we're 2 points. Numbers 33 through 36. There's 4 of them. Those are worth 4. And anytime you see a number 37, that's going to be worth 6. We'll also say it like in the title above it. So like these were all under the part 3. They don't just like randomly skip, Abram, like a test. Like sometimes on a test for a subject, it might like bounce back and forth. This kind of goes in order. Probably today, Kyle. For this, Mark, yeah, you don't have to write. Well, it did say complete the square, so you do have to show that process, but you don't have to explain it. It did say completing the square, so you'd have to show that. I mean, a math teacher looking would be able to tell, did you actually do CTS or did you just kind of cheat or something? If it doesn't say justify, can you just put the answer? Yeah. Then yeah. Yeah, Kyle, those we're not talking about multiple choice. So 24 through 32 are the written. 25 through 32, sorry. What did I say? 24 is a multiple choice. Yep. All right. Anything else, guys? I don't want to hold you too late. Thanks for coming for those. What did we get up to? Anyone pay attention? What was the highest total we got? 50? Something like that. Thank you, 50 people that came. I'll post this reporting today. Sometimes it takes a while to upload because it's like a half 45-minute long video file. All right, guys, have a good one. We'll continue with more practice regions. I might make a post tomorrow, even though I know you guys are off, of like, hey, if you want to get a head start to try this one. All right, guys, have a good day. Enjoy, and I'll see you on Wednesday.